idea, or if you have a busy schedule, you may, there are cameras, there is a projection, you do not need special equipment, you just dial this number in the link in the browser and it will be virtually present. You have camera, you'll pop up in the corner, you can ask questions.
That's interesting.
There will be a couple of meetings when we all need to be here, but it is not everyone, not every meeting. And, I will chat a little bit about the course today, but you see that not everyone who is in the emails is here today because there are some scheduled conflicts. So you may either do a pool or just personally chat, or selecting maybe more optimal time if this one is not the best for everyone. For me, this one is the best, but I'm flexible. So maybe during today and next night, just think about your schedules and options on Tuesday and Thursday. We will maybe make a vote for majority for time slots when everyone is largest number of possibilities are happy. You can sacrifice that being.
So, is there any students who have a high conflict with this course?
There is one student who.
I think we have. I'm not sure why we have that confusion.
Okay, but I'm wildly, broadly available, like from 7 a.m. to 9 p.m. And I think we can tailor times that you please everyone. So there is a those books are recommended. Nothing is mandatory. You do not need to read any books to become successful in class. But these two are not challenging. They do not need much of the specific preparation. They are more like practical guides. This one is not in computational chemistry at all, it's more physical quantum chemistry with review of the chapter, but since it's like 700 pages and related to our class maybe 40 pages. So they are very well digested. This is oriented like quantum theory for chemists, so it's a lot of adapted because quantum theories are originally designed for physicists. But we do not need top level theory. We will be basically using software to model materials and their properties. But some minimal level of theory is needed, not in the order so that we sit the right equations and correct each other, hopefully, but in order that we speak the language of scientific community for people who are involved in modeling materials and their properties. And for computational modeling materials, there is a proper language that helps to progress if you select this pathway, if you want to get into particular research. This one is so advanced that I don't recommend it. But you can look around. So we will cover maybe the first 50 pages, and then there will be very advanced material that would not be possible to cover in the time. But it is very rigorous, and every word in this book is absolutely is a textbook for those who write as other textbooks. And I think I ordered this three into the bookstore if you ever decided to use it. But those are not mandatory, they're totally just recommended. So, when there will be majority of class activities, I may repeat quickly what we did today so that everyone is on the same page. This is basically the structure of the course. So there will be 4 chapters, and at the end of each chapter, I will suggest that we do presentations. I will write one lecture and do it. There will be some minimalistic cohorts, but they are very small percent of the they are more for not to grade you, but to show feedback, what is understandable and what is not, what I can adjust. So I will toss in maybe once per 2 weeks or once per week a quick question is to see to provide feedback to me so that I can give more details or speed up. And this one lecture, one meetings, it's just when everyone is invited to attend in person. Because doing presentations through video conferencing is not easy.
So presentations individual or in group? So group.
So we will split. There will be specific material, very much related to the course. I do not want to say the word exam because it is not exam, it is much easier. But in some very far relation, it will be like midterm presentations. But do not, I do not like the word midterm or exam because it's scary. It's like testing knowledge at the big. It's more like showing your positive emotions to the course, and maybe sharing some what you find in the books or online or so. About 15 minutes, 1 hour will be split in the amount of use of the class, and we'll do 4 minutes presentations individually coming up and telling us the overall quality. And a lot of things in the class material will be repeated because I'm doing it for 6th, 7th, 10th, if they are recorded. I hope that every year I'm doing better, but who knows, maybe less. So when we look at the content, and the 4 will be the same. Ideas. I'll share links to each lecture. Or you can either sit here, connect through the video conference, or just watch it, or do all 3 and 7 at once. So there will be one more meeting, or 1 meeting before the last presentations when everyone is done. So 5 times during the lecture time is everyone. You're very welcome and encouraged to come other, but if your schedule is stuck, put it on. Then there will be about each Wednesday there will be a practical session downstairs on the computer. The room there is reserved 3 hours, but we will be living much more. So do not disturb. So investment in time will be very low. I will try to finish this virtual speed within an hour, and it will be a little longer than an hour in the computer phase. So we have about approximately 4 months, and there is approximately 4 chapters. So if we will get acquainted, I will learn about your profiles and your interests. Right now I just want to give a quick summary, but I have a intuition that you are interested, your primary interest is not into the deeper academic principles of the subject, but more into practical applications for modeling actual materials and their progress. In this sense, the chapters will be most important. I'm not telling you the rest is completely not necessary, but this will be most practical. So the first chapter will be background theories and an important thing about organization. The lecture materials will be just for the language, maybe some equations that you can copy paste in your thesis or your application. It is not required, not demanded that you will be deriving. It's more like you recognize them and explain how they are connected and complete the codes in real language. But it isn't, if I do not spend time on it, then reports that you will write will not look pleasant to professionals in this area. If you absorb a little bit of the language and equations, what you write will be competitive with local skill. You do applications, describe it using this language, and it will be competitive. At the time that we invest a month for chapter 1, at the same month we will do practical things in the lab that will partially complement the chapter 2, but it will be not literally the same things. So for the first month in the lab, we will do molecular modeling, and some of you may have been exposed to just draw molecules or materials, substances, put something in that sort of. It's like it's right, but it is a critical part without doing models on anything per se further. Some people who work with crystals can import molecular models from X-ray diffraction and completely avoid drawing materials. But we will overview what we're getting. We will also get experience in, and I don't know how many of you are already exposed to Linux and supercomputing environment. You will slowly but surely get it. I'll explain it in more based on time in the lecture. So, what are molecular models? What are general goals? And how to split big pool of modeling materials and their focus on little tasks that can be solved by the computer. Then this one will chapter on will go mostly about positions of atoms and geometries of the model. Then a lot of the materials are related to the electronic state. Conductivity will cover material explain material changes conductivity based on sorbate. It's for other monoxide sensors. So one needs electronic products. And the second month we'll deal with the basic, most simple theory in focus called particle theory. No one in modern world does it for competitive results. But it is like a cornerstone that sets up the language, definitions, concepts, and is mostly developed with Google coding. Although it has some approximation, but they are important. So if you are looking into applications of modeling real materials, it's not as useful. You're not coded in your reports, but it is like having a part that sets up data with these concepts of orbitals, acquisition areas, things that are totally used. In the lab at this time, we will go over so-called Gaussian software, building standard for chemistry, integrated tool that allows to create models and characterize them with all possible fields in work form that standing up from the workplace. While other pieces of software you will need to funnel files and then available for that. So the piece of code we covered during this month of the second month of the lab will be quite easy. We'll set up skills, concepts, but it will be a good fundament. And then in the third month, which will be like March, we will cover so-called basic functions. So it is not the most exact, but it is a workhorse. But the best, the very best balance precision and this may change in several years, but by today it is changing. And, in order for you to be competitive in the products and papers of this, we will go over those parts of the principles and theorems. We do not need to memorize, derive, we need to go over. And at the same time, during the labs, we will be exposed to software called the initial software package, which is one of the champions. If you need mid-size models, sufficient precision and alternate properties, it is very powerful tool. It is overlooking possible software reports, and this one seems more powerful. During this manual means during the month we will get some skills and practical hands-on experience, and then at the last meeting of this chapter we will chop practical skills from among people in the course, and we will basically teach each other how to use the software and how to simulate it. Which from previous years of doing this course, this one is considered as the most mostly enthusiastic by class attendees, and by the up when lectures were placed on YouTube. This one got largest number of hits. It seems like most practically important part of the course. And do not worry, we will absorb information during the month. This presentation, then we will visit 5 minutes. Nothing special. With the time space in this white space, you will need to finalize your choices for your research project. And while during the month of April, I will be delivering some advanced concepts for particular properties and advanced theories, high precision, time in the lab will be used to invest skills from all previous things into your projects. Select problems, solve computationally, and start writing. And sometimes at the beginning, we will compose reports for the found of your preferred problem, and at the last meeting, we will present your research. Any questions?
So on projects, we need to. I'm not familiar yet with this quantum chemistry. Projects could be just related to this course, or, for instance, our major is molecular dynamics, and I was wondering if we can find some connection with
Absolutely.
our current research.
Absolutely, yes.
It could be more maybe efficient
Yes.
to maybe at least publish a, I don't know, publication paper or something like that.
I believe we should find healthy merger. And I know that you may be already experts in force field molecular dynamics.
Not expert, but some
On the way to become one, right? And so this software also does molecular dynamics.
Okay.
But do you do Reacts FF? Any of you? Reacts FF.
It's a force field. It's a reactive force field.
Yes. Do you read?
I just heard about it now.
So we cannot do everything in this meeting, which I promised to make short, but I will learn more about projects of your interest. And the third, molecular mechanics, molecular dynamics is used for like conformations, docking, absorption, but also there is an important chapter of molecular mechanics when molecules and solids experience bond breaking and formation. Right?
Yes.
Do you do molecular dynamics with bond breaking?
Not yet.
There are objective challenges. If you do force field, majority of force fields, except Reacts, do not allow bond breaking. And there is a
Usually they use harmonic functions, and we are okay models that. Yeah.
But there is a huge number of important problems where bonds are broken. Like in chemistry, you do photocatalysis. When you have a reactive surface which you excite by light, or simple, and then it water breaks hydrogen and oxygen, or like simple electrolysis. So bonds are broken and formed, and it is industrially important around 4 pairs. So this software gives this option, and one can try to do the same problem by your favorite software and by this one, by results. If bonds are not broken, results should be the same. If they're broken, this one could be more helpful. But it is part of my employment to get some technical information. But personally, it is much more important to just dive into research projects and get new ideas. So maybe I will communicate you some inspiration. Maybe you can get some inspiration for the project. So it will be healthy knowledge.
Right. But as you said about the force field, I don't know, you are familiar with course here in modeling in molecular dynamics?
I'm not doing it, but I'm familiar.
One of the major problems is that, for instance, with coarse grain modeling, we cannot capture the charge. So defining the force field is very challenging for this kind of
Yes.
model. I'm not sure if we can utilize quantum chemistry to, for instance, define force fields to adjust the force field and the parameters for such that molecular modeling.
It is possible, and it will be very beneficial if your systems are large. If it is like more than 1,000 times. If your system is less than 1,000 or better, like a couple hundred times, one can directly use ab initio molecular dynamics that has explicit treatment of charges, and the problems that the challenges for traditional molecular dynamics are resolved. So just run molecular dynamics that automatically takes care of charge distribution, bond breaking, and it is one of the options. I'm very happy that I'm not mounting to myself with the discussion. For a poll, we actually started. So, okay, I'll chat more. Does any of you need to leave literally? Do you need to speed up right now?
Finish up with
Please, okay. But let me know. We all are all considered in this of this class as young colleagues. Everyone should be.
I will have a class at 12:30.
Oh, we will finish definitely. Okay, sure. And probably on tomorrow at evening when hopefully everyone will come. I will either put a sign up sheet or send email with little code so that we select object time. So maybe you already doing more of this. If you are growing experts in course and you are also could be exposed to the spirit with periodic boundary conditions of this. So you just teach the rest of this. Share experience. It is also something that we may be exposed to because there are different pieces of software on this class. And by the way, when do you run the models? In which series? Okay, yeah, there is a CCAS. Huh? Anything else?
supercomputer and C++. So
But any other supercomputer in addition? Okay. We will open accounts on another computer which is important. So maybe we can get higher productivity. So if you are force field experts, first chapter will be like childish game. But the second month we'll be diving more into electronic properties. Maybe you will find something interesting and exciting. So, states of electrons, which takes certain energy, transitions between them, the density of electron states, which defines whether the material is a conductor or a dielectric. And we will dive deep into this terminology and transform in this concept. And so we mentioned charge transfer between species. We will also get into how the electrons localize in one group model or another group model. And this is the part that I consider most pleasant and interesting because it is molecular dynamics that we already experienced, but it application molecular dynamics which allows charge transfer, charge distribution, excited states, and then the forces on each atom can be different depending on the electronic state. If you shine light or apply electrodes, the molecular dynamics of your models can be different. So each atom will experience different forces. And if one does have an issue of molecular dynamics, one doesn't need to reparameterize. It's all there. It's more universal. And this is probably what you already, right? You can store where you molecular dynamics. So one day we may rename this course from computational chemistry to advanced molecular dynamics. I don't know, maybe it will attract broader interest. And the third will be additional chapters, which are not primary and better, but at least they will open the door to someone that will interested. So if your model is being electronically excited or charged or touched contacts, this time it may change it for next. One needs some specific tools, methods to see how it changes. If the transistor or diode in the circuit experiences different signals, how electronic states are changed. And if molecule or material or part of its screen, like in the diode is sensor, been excited with life, you will not stay excited forever. After life is removed, there is some relaxation process. That's without excitation. We'll do not much teamwork because our teams. If there would be like 30 people, we would bundle in teams and then each presentation would have 2 or 3 of these. Right now we have a luxury of doing technical writing is this part. And it's not a secret. Before publishing this little booklet, your reports will be offered across the class. We will write reviews about each other. Not about each other, about works of each other. And from previous years, this part gives a tremendous increase in the quality in the sense of being logically organized. Just even if no one reads it, but you expect that someone will read the writing. I'm not if I'm writing for myself or I'm writing for someone else, I'm writing much better effect because before I see someone who read presentations and put your molecular units videos on YouTube, maybe competing with my likes.
And is there any final exam or whatever the grading of this course?
Just do not resist no offense to look at your grades. There will be homeworks, there will be these presentations, and if you just do all of them, I think like it should be very good. Okay. There is, I do not think it will be so much intellectual challenge that any of the class attendees will try hard at this moderate amount of effort you will excel in getting all the material. So basically, it's responsible effort needed to results in the perfect.
You just mentioned another competition course.
Yes.
We will use pictures. So. Okay, so all of us can accept that resource or we provide some proposal for
I will mention it in the lab. You will be enabled with access during the class, and if you need it further, it is very much negotiable. But the facility that we will be offering its Department of Energy facility, and they, unlike CCAST, they assign specific number of hours per user per year. And like in CCAST, if you have an account, you can use it infinitely as long as other people can use it. On others, one means so many hours per year, and then if you're over it, you cannot use it further. So there will be some limitations, but they are not careful. There will be. So, let's fill these boxes. But I don't know, maybe even I can either write myself or boxes. Let's just go one by one and write something. I will have. So it is a summary of the course. Okay, please come here. Yep. Yep. So you can. Can I go for tech support?
Excuse me?
Yes.
There is something wrong with the screen. Can you open? So the effort that we've been doing in the course will merge together some theories. So whoever will be filling this box can write the word theory here. So just write with your finger, theory.
Finger.
With finger, yes. In the box. Yeah. Just word theory. Or you can write Schrödinger equation if you want. The word with distinction.
The time point is not good job, but it is.
Just try your best.
It's better.
Yeah, excellent, thank you. And you know from quantum mechanics, main theory is Schrödinger equation.
Right. It's like that.
Can you fill one of the boxes? You are in the right place if you want to do computational chemistry.
I'm talking about cellular towers replacing all over the city of Fargo. Bismarck, Grand Forks.
Very interesting, but not as academic as our activity here.
5G.
Okay, that's,
Thank you.
thank you for doing this. It is important for all of us. Problem models. Just you draw model or write with fingers.
Model.
Yeah, models. Excellent, thank you. We work as a team. And then we do have a simulation. I'm also knowing. Which needs computers, right? Hardware. So you can write it what hardware in
Hardware and software.
well, in one box hardware, in another is software. Software. In another you can write hardware. Yeah, yes. Thank you much.
Thank you.
And in the last box, you can guess what you get out of the simulations. And if you're in like science, engineering, what is the output about materials? Observables, properties. Like properties.
How do you spell it?
Oh, whatever it doesn't. Properties.
Oh, properties.
Excellent. Thank you very much. Let's check. Yes, last year there were atomic model structure. Models, atomic model structures. For instance. And when you have these observables or properties, you can compare them to experiment or to whatever industrial application products. And you do it on computers. So basically, it is some summary of the course. If a stranger catches you in a superstore and asks what is computational chemistry, you can explain modeling properties of materials with software and hardware. I will go next time. I will just start this material so we have less for Thursday. If you have a general idea of where we will be intellectually doing. So, if we are modeling materials, all materials are molecules. All materials are made of what? Huh?
Atoms.
Atoms. And atoms are made of
Electrons, protons,
Newton
neutrons.
consists of
so electrons, which are negatively charged, and nucleons.
neutrons and neutrally charged atoms are positive.
Mm-hmm. Good. And for this class, you don't care about the protons. You just need nuclei with a certain mass and certain charge. We are going to do it. And so here is the plan. What we need to accomplish on Thursday, although one can accomplish it in 5 minutes. So you need to recall what our mode is, and if you want to model something that has electrons, we need to take into account the fact that electrons have very quantity features, quantity properties, and they are both particles and waves. Clouds. Okay. So, if we want to, we are not mathematicians. We are not putting a goal to make big theories, but we need to be exposed to basics. And before we set up a software to model properties with nuclei and electrons, we need to convert our problem onto mathematical language. It is unavoidable, and we need to do it correctly. So, if we want to set up mathematical language for atomic model or nuclei and electrons, we need to know how many of each type nuclei, how many electrons, they all are the same type. And then, for short interval of time, temporarily, not forever, we can assume that electrons are protons for each other. Then, what do you do in physics from the theory if you need to solve generally any problem? Yes, but which equation? What is the major concept in physics if you have a system of any objects? There is a very general concept, general idea that is universal and with very minimal exceptions.
Hamiltonian.
Perfect. Perfect. You need to write a Hamiltonian. And you can, from Hamiltonian, you can go to units. Or you can go to a Lagrangian equation. You can go to Schrödinger equation. So you need Hamiltonian. What is Hamiltonian?
You just said it's based on the Newton second law.
But Hamilton is the name of the person, scientist. But which observable does it correspond to? In which units we measure Hamilton?
Meters would be this.
Which units, like meters, seconds? I'm provoking. I'm not being too more. I haven't given right
So
answer.
for sure it's the largest scale. From
Units, like
centimeter to even meter.
centimeters, meters are units of length.
Length, yeah.
Seconds, picoseconds are units of time. Which other physical observables, physical units? Mass, velocity, what else? Acceleration. Huh?
Momentum.
Momentum, yes, very good. What else?
Acceleration.
Yes, good. What else? if I drink a lot of coffee, what do I have? Yes. So what are units of Hamiltonian? Yes. Yes, it's energy. So it's observable of total energy of the system, right? Which can be measured in joules or calories per mole or out in volts or hartleys. There are different units, but it is energy. And which two forms of energy you will know for sure? I have no doubts, you just need to pronounce it. Okay, good. So heat is when you like
Potential energy, or you're talking about
potential and heat is good. Potential energy and heat energy, but there is a little
Kinetic.
yes, potential and energy. So if you want to convert description of your molecular model into a mathematical language, you need to set up an equation for Hamiltonian, which is kinetic energy plus potential energy, right? So we need to make a connection between, we need to set up where our nucleus and electrons are located in space, record positions of all nucleus, as you do in molecular dynamics, record positions of all your electrons, and then assign velocity for each nuclei and each electron. And as soon as you have this, like 4 types of parameters, positions and velocities for each object, out of this variables, you can set up the Hamiltonian, right? You agree that it is quite universal approach. So this will be the goal. Maybe I leave it at the desert for next for Thursday meeting after we decide what to do. But today we will just do planning. So we will do this list of position, momentum, or velocity for nucleus, electrons table, right? Then compose them into kinetic energy and potential energy. And then what can one do if Hamiltonian is known? After I know Hamiltonian, I cannot sell Hamiltonian. I cannot publish it because it is like a strange job. We need properties of molecules and particles. How do I get from Hamiltonian to properties? How do you get from Hamiltonian to molecular dynamics? How do you get from Hamiltonian to Newton equation of motion? Wave function, it is a direction that I want to read you. And the intermediate question, if you need Newton's equation of motion, you can take derivative of Hamiltonian over position of the particle that you're moving. And derivative of energy over position will be force. And force equals acceleration times mass. If we move ion number I, we take this derivative, it will be acceleration I times mass, and acceleration is ion I. So this is Newton's second law, right? But as soon as you know Hamiltonian, is mass of ion I, and this we can write it down and then program it and get it. But we do have electrons, and you mentioned correctly that there should be wave function. So how do you get wave function out of Hamiltonian? Which equation do you solve?
Your call will be disconnected.
Ukrainian function.
Shredding.
Okay, probably it prompts us to have 1 or 1 hour for the meeting. Schrödinger equation, right? So as soon as we know Hamiltonian, we can find wave functions and energies. So next on Thursday meeting, whatever time we decide to have it, we will make a figure for ions and electrons, write down Hamiltonian, and describe how to plug it into Schrödinger equation. This will be a great achievement for actual lecture number 2.
Can you please repeat what we have to do next? Make a figure of?
Yes. So here is the plan. So we define molecule. We set up the list of variables, which will be positions and velocities of electrons and nuclei. We write down the kinetic and potential energy which composes Hamiltonian, and then we plug in this Hamiltonian into Schrödinger equation for the goal of finding energies and wave functions. Okay? So, any brief questions?
Oh, what's the meaning of R again? Is a position?
Position, yes. Okay. I'm not going to further details because it looks like our time is up. More questions? If no, meeting is complete. I look forward to seeing you Wednesday 5 p.m. and please develop ideas about your preferred times.
Okay, sure.
Thanks.
Okay. And we are going off record. So if you want to criticize something or someone,